The last thing we're going to look at in our introduction to graphing is graphical solutions. So we're going to use a graph to express and identify overlapping points. Particularly, this is useful in the case of an economic analysis. So we're going to be able to show fixed cost, variable cost, sales price, revenue, and plot and profit graphically. We're going to identify the break-even point of an economic process if one exists. So what is a break-even analysis? A break-even analysis you use to graphically visualize the cost of producing a product and the revenue from selling that product to assess profitability. Important terms are costs, that's the money you must invest to make the product, fixed costs, equipment and building, variable costs are your labor, energy, and material. Revenue is the money made selling the product, that's your selling price. Loss and profit are the difference between the costs and the revenue. Break-even point is where your cost is equal to your revenue. So let's look at a graph that we have here. We have a total cost versus total sales graph. The y-intercept of the total cost line is your fixed cost. The slope of the total cost line is your variable cost. The y-intercept of your revenue line is always 0. You never start with any revenue, and the slope of the revenue is your selling price. Your break-even point is the intersection of the total cost and revenue lines. To the left of your break-even point, you're at a loss. To the right of your break-even point, you are at a profit. So your revenue line, y is your revenue, your y-intercept is 0, your x is the number of products sold, and your slope is your selling price. For your total cost, your y is your total cost, your intercept is your fixed cost, your x is this number of products produced, and your slope is your variable cost. So how many fire ant destroyers must the company produce to break even? So first we want to find where these two lines intersect, and these two lines intersect at 170,000 units. How many fire ant destroyers must the company produce to sell and make a profit of $500,000? So to make a profit of $500,000, you need the difference between your revenue line and your total cost to be $500,000. So we find where that occurs, and then we drop down and we look at how many units have been sold, which is 260,000 units. What is the sale price of one fire ant destroyer? So we need the slope of our revenue line. You can do this at any really points. So your selling price is the slope of our revenue line, which in this case is $10 per unit. If the sales price of one fire ant destroyer was increased by $1, how many units must the company produce to sell to break even? So we actually need to plot a new line with a new slope. If we do that, we are going to get a new break-even point, and the new break-even point is 140,000 units. Again, if our sales price was increased by $1, how many units would the company produce to sell to break even? If it is decreased by $1, we have to change the slope down, and we will get a new line, and our new break-even point is 210,000 units. So you can use these graphs to determine information about your costs. So what is the sales price of one unit before the upgrade? So before the upgrade, we want to look at the slope of the line of blue. What is the initial cost of the equipment and other fixed costs necessary before any solar modules are made? And what is the fixed cost of the day the upgrade is completed? So the slope of the blue line is $10 per unit. And what is the initial cost of the equipment and other fixed costs necessary before any solar modules are made? So you have your fixed cost of, the sales price for one unit before the upgrade is the slope of the black line. The initial cost of the equipment before any solar module is made are the $500,000, which is the y-intercept of the blue line. And what is the fixed cost the day the upgrade is completed at day 5,000? Your fixed cost would be the y-intercept of our new cost line, which jumps here, which is $2.5 million. When does the company break even after the upgrade? Well, we need to look at the intersection of the revenue with the upgrade versus the cost of the upgrade line, and that is approximately 75 days. Notice it occurs 75 days after 500. And how many total units are needed to be sold to make a profit of $1 million after the upgrade? So I need a difference between the orange line and the red line to be $1 million, which occurs after approximately 332,000 because after the upgrade, the plant can make 1,200 units per day. Based on the number of days that it takes to generate that profit, you can calculate the total number of units sold. So that's how they do a basic break-even analysis. They're useful for determining the intersection between two lines and just further gathering information from our plots. And next week we are going to work on looking at trend lines and further determining information from our plots.